Hey everyone. Today we're going to be focusing on day 2 of the hyperbola. So these are hyperbolas that are not centered on the origin. Before we begin, I just want to review some of the notes from yesterday. Ooh, let's get rid of that. Well, I won't worry about that. So hyperbola comes in two different equations. We have x minus h squared over a squared minus y minus k squared over b squared equals 1. That's when our hyperbola is going to be kind of going in the x direction. And that happens when the x is the positive term. When the y is the positive term, y minus k squared over a squared minus x minus h squared over b squared equals 1, then our hyperbola, our vertices are going to be along the y-axis. A squared, remember, is always under the positive term. A is the distance from the center to the vertex. B is the distance from the center to the endpoints. C is the distance from the center to the foci. C squared equals A squared plus B squared is our formula to find missing information. And our asymptotes, we're always going to use the center as our point. And then in point slope form, we're going to do y minus k equals plus or minus rise over run x minus h. And remember, rise over run is the rise over the run to get from the center to the edge of your rectangle. So let's get started with our lesson. We want to find the center, vertices, endpoint, and foci. We're going to graph this, and then we want to write the equation of the asymptote. So very similar to where we left off yesterday, except now our hyperbolas are going to be shifted. So the first thing we're going to do, and I'm going to write this stuff down here so I don't get it in the way of our hyperbola, because I know it's going to be up in that top left corner there. We're going to identify our center. Our center, H and K. So our center, we take out the opposite, -4, 3. There's my center. Now we're going to plot our vertices. So we go back over to our equation. The x term is the positive term. So I identify a squared as 9. A is plus or minus 3, and that's my movement. So I'm moving in the x direction, 3 boxes in either direction. And those are my vertices. So the coordinates, or the ordered pairs for the vertices, become -1, 3. I don't care if you count boxes or if you add or subtract, and -7, 3. Our endpoints are the b value. So I go back over into my equation. B squared is 1, so b equals plus or minus 1. I'm moving in the y direction now. Off the center, up 1 and down 1, my endpoints. So the ordered pairs for my endpoints, -4, 4, and -4, 2. At this point, this is where I would make my rectangle. I do it in this order because I want my curve to go through my vertices. So if I do it now, I won't be confused later. Make my asymptotes to the best of my ability. I'm going to try to hit the corners of this rectangle. That wasn't very good. And now remember, our actual hyperbola is guided by the asymptotes and goes through the vertices. Lastly, we're going to plot our foci. Again, if we recall from yesterday, there's our formula. c squared equals 9 plus 1. So c squared is 10. C is plus or minus radical 10. Now I think I have to count radical 10 boxes. So square root of 10 is a number between 3 and 4. 3 squared is 9, 4 squared is 16. Working off the center again, we're going to count 3 and a little bit. 3 and a little bit. There's my focus. Go in the opposite direction. 1, 2, 3. Oh, it's nicer when there's no lines. There's my focus. The ordered pairs with a coordinate. I started at -4 and I went up and down, or to the right and to the left, radical 10 units. And the y value of each ordered pair is still 3. Lastly, we're going to write the equation of the asymptotes. Oh, we could squish it over here. Remember, the point you're using is the center, which in this case is -4, 3. And we're just going to pop it into our point slope form. So y minus k, y minus 3 equals plus or minus rise over run. If you want to go in your picture and count boxes, rise up 1 unit over 1, 2, 3. X minus h, or x plus 4. You guys may be realizing by now that the rise over run is always some kind of combination of the A and the B movement. It is. I just don't want you to have to memorize formulas, so I always just use rise over run. And there's no reason to convert it into mx plus b form. That is a perfectly acceptable answer. Leave it just like that. In our next example, we're going to find the center, vertices, endpoints, and foci. We want to graph. We want to write the equation of the asymptotes. Same steps. Except now when I go to look at my equation, it's in general form. So I need to complete the square. And if we remember from yesterday, or when we completed the square with the ellipse, we can only complete the square if there's a 1 in front of the x squared or the y squared. So this time we're going to have to be really careful with that negative sign. The method is going to stay the same. I want to group my x's. Negative x squared minus 2x. I'm going to group my y's. Plus 4y squared minus 16y. I'm going to move the 11 to the other side. Now I'm going to set up with my factoring and leaving a space to add a number. Since I have a negative sign in front of the x squared, I've got to factor that guy out. X squared plus 2x plus something. Since I have a 4 in front of the y squared, I have to factor that out. Y squared minus 4y plus something equals negative 11 plus something plus something. I may run into my picture. I hope I don't. Now we're going to work on the complete the square part of the problem. Middle term, divide by 2, square it. 2 squared, 1 squared is 1. I'm multiplying it by -1 before I move it over, add it to the other side. -4 divided by 2, -2 squared is 4. Multiply by 4 before I bring that over to the other side. Now clean this up, write each of them as factors, and add the numbers on the other side. So I have negative, this is going to be x plus 1 squared, plus 4 times y minus 2 squared equals -12 plus 16 is 4. I have to get this equal to 1, so I divide each term by 4. negative x plus 1 squared now it's really obvious which is the positive term and which is the negative term. Okay, so it's kind of nice how it worked out there. So from this point, we want to identify our center, vertices, endpoint, and foci. I'm kind of giving myself little reminders of what has to be shown. So my center, remember, is the h and the k. H is always with the x, k is always with the y. My center is negative 1, 2. Negative 1, 2. That's my center. My vertices I get by a movement. So I go to my positive term, which is the y, and I identify a squared as 1. So my a movement is up and down along the y-axis. So I'm going to go to my center, move up 1 and down 1. The ordered pairs for the vertices, negative 1, 3, and negative 1, 1. B squared is 4. B is plus or minus 2. B is under the x, so I move off my center 2 units in the x direction. These are my endpoints. The coordinates of the endpoints, 1, 1, negative 3, 2. Rectangle, asymptotes, curve. Rectangle, asymptotes. I know the asymptotes are a little tricky, just make the best you can do. My asymptotes are going to be going through my complete the square. Not a big deal. The curve goes through the vertex, is guided by the asymptotes. Through the vertex, guided by the asymptotes. Double check, the y is the positive term. The vertices are kind of in an up and down position, so we're good. The last thing that has to go on are the foci. The foci, we're going to get their place by plugging in and using our formula. 1 plus 4. So c squared is 5. C is going to be plus or minus radical 5. Square root of 5. 1 squared is 1. What am I doing? Yeah. Square root of 5 is going to be a number between, well, 2 squared is 4, 3 squared is 9, so it's a number between 2 and 3. 1, 2, and a little bit. 1, 2, and a little bit. There's my foci, foci. Write the ordered pair. So I was at negative 1. I started at a y value of 2, and I went up and down radical 5 units. The hyperbola is a little tricky, so you have to be really careful. Lastly, we're going to write the equation of our asymptotes. Remember, our point, we're going to use our center, and then we're just going to plug into our formula. Y minus k, which is 2, equals plus or minus. Now we're going to do our rise over run. We're at the center. Rise up 1 unit over 2 units. Rise over run, x plus 1. We can leave our equation just like this. You don't have to worry about writing it in mx plus b form, and we are done. Now let's try to write an equation of the hyperbola with the given problems. properties. So writing an equation, again, very similar to what we did yesterday and the day before with the ellipse and the day before that with the ellipse. Always start by plotting your information, identifying the equation to use, and then plugging in the values as you get them. So I have center, I have one focus and one vertex. I'm going to plot my information. My center is at 1, -2. I have a focus at 4, -2. Center, that's a focus. And I have a vertex at 3, -2. This distance is your A value. This distance is your C value. So the distance from the center to the vertex is, A is going to be 2. And the center to the vertex, 1, 2, 3. C is going to be 3. Our hyperbola, if we were to graph this, it's going to be an x version, right? Where the x is the positive term. X minus h squared over a squared minus y minus k squared over b squared equals 1. Now we're going to slowly just start putting this information together. X minus 1 squared. A is 2, so a squared is 4. Y plus 2 squared. B squared we don't know, so we use our missing information formula. C is 3, c squared is 9. So b squared is going to be 5. And that's working backwards to get the equation. We have one more equation. I may skip over this. I want to review rewriting the following equation. I want to review the completing the square one more time. Then I'll go back and I'll do the last problem kind of quickly. That way, if you don't feel like watching it, you don't have to. Completing the square with this hyperbola. So I have root my x's, x squared plus 8x, root my y's, move my constant to the other side. Ooh, this one's easy because this guy doesn't have to be factored. Now I'm factoring out a -3. Middle term, divide by 2, square it. Middle term, add it to the other side. Middle term, divide by 2, square it. I'm adding a 1 inside, but I'm really adding a -3 to both sides, right? I have to remember to just multiply it by -3 before I add it. Now I'm going to write it in factored form and clean up my other side. This becomes x plus 4 squared. I didn't want to write that on the bottom there. X plus 4 squared. Y plus 1 squared. -4 plus 16 plus -3. So that winds up being 9. Last step is divide 3 by 9. And your finished version I'm going to go back up and finish this last problem here. I'm just going to kind of do it. I may not say it in words. You can practice it. You could stop the video if you've seen enough. It's okay by me. My center. I have a focus at 1, 1. I have a vertex at 1, -4. Should have read So A is going to be that distance. C is going to be centered, focus that distance. My A value is 2 units. My C value is 1, 2, 3 units. My hyperbola is going up and down. So the up and down means y is positive. When I go to plug in my point, I have to be really careful that I put the h with the x and the k with the y. A squared is, A is 2, so A squared is 4. B squared I have to figure out. Oh, every example, B squared is 5. How did that happen? B squared is 5. We're equal to 1. And there's your finished product. I hope this video helped, and I'll see you soon.